Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session, we have started the simple harmonic motion chapter. So where we dealt the basic concepts like what is simple harmonic motion, first what is periodic motion and what are the different types of periodic motion, and what is a harmonic motion and what is simple harmonic motion, and what are the basic terms that are related to the simple harmonic motion, and what is the equation of the S.H.M. So that's what we discussed in the last session, right? So today the lecture number 2, it's going to be an interesting lecture. So where we are going to solve n number of questions as well. So our today's motto is, so the questions on equation of S.H.M, then S.H.M as a projection of uniform circular motion. So here based on this in JEE they asked previous year questions, so we'll solve them, and so in between these two we'll solve a number of questions. Okay, chalo. So as usual I just need your attention for the next 1 hour, below 1 hour only. So just be with me, avoid all the disturbances around you guys, and at the end of the lecture it's very important to prepare your own short notes. Chalo. So and the students, those who are in class 12th and droppers, you guys should gear up your preparation guys, okay, because the competition is very high, so every minute counts from now. Okay, so solve the previous year questions, so do attempt the mock tests, okay, revise the previous topics, complete the backlogs. So this should be a routine for you. Okay, chalo. So let's get into the today's topic first. So the differential equation of an S.H.M. So we see if a body makes S.H.M, so let's say this is a mean position at x is equals to 0. So from x is equals to 0 to it moves to the extreme. This is a right extreme position where x is equals to plus a we call, right, and this is a negative extreme, left extreme. So this is the left extreme where, so the x equals to minus a, x equals to minus a, right? Chal. So we know that the acceleration is equals to minus omega square x. In the last class we discussed about it, and we got the formula for the acceleration as a is equals to minus omega square x, right? Chalo. So now the particle which is making S.H.M, so let's say it's a displacement. So the displacement of the particle, let's write the displacement from mean position, we call it x. So the displacement from the mean position, let it be x. So if the body is moving towards the right extreme, we take it as x is positive. If it is left, x we take it as negative, right? Chalo. So now, so if I have to find the velocity, so simply the differentiating it, the basic kinematics we have learned, right? So that velocity will be, the velocity v will be equals to dx by dt. This point is also clear? Yes sir. So then what will be the acceleration of the particle which is making S.H.M or performing S.H.M? So the acceleration a is equals to simply dv by dt. So dv by dt, so which is nothing but, so the d by dt of, so what is the velocity here? So the velocity is, in place of velocity I am writing, so the dx by dt. So here it's going to be, so d square x by, so the dt square, d square x by dt square. This is the acceleration a we got. So now what I am doing is, so let me consider this equation again. Okay, so the acceleration a is equals to minus omega square x. Now in place of a I am writing, so d square x by dt square. So d square x by, so the dt square, so is equals to minus omega square x. So bring the term to the LHS side. So then I can write, so the d square x by dt square plus omega square x is equals to 0. So this is called the differential equation of S.H.M. What is this one? The differential equation of S.H.M. Understood? A basic thing. This is the differential equation of S.H.M. So just have the idea about this. So next we'll move further. So what's the equation for the S.H.M? So basically there are many equations for the S.H.M. So we consider the general equation of S.H.M as the general equation of S.H.M as, so where the y, if the particle is making displacement in the x direction, we consider the x is equals to some equation. If it is performing S.H.M in the y, so then we take y is equals to. So here I am considering, so the particle is performing S.H.M in the mean position, to and fro motion it is making. So the x is equals to 0 is the equilibrium position or mean position. So plus a is a right extreme and minus a is a left extreme, right? Chalo. So now I am writing here, so the x is equals to, so a sine omega t plus phi. So omega t plus phi. Okay. So this is a most popular, the general equation of an S.H.M. So this can be, so the x is equals to a cos omega t plus phi. So this can be this also, like the equation can be this also. Okay. So either this one or this one. So not only these two, so there are many. Okay, as the class progresses, as the lectures progress in this chapter, so we will see the different forms of the S.H.M, the combination of two S.H.M. So there will come across some different equations for the S.H.M. Okay, clear guys this part? Everyone done with this? Sure. So here one thing, so this whole thing is called phase. This whole thing is called the phase. Right. So and then this is called the initial phase. The phi is the initial phase. So if you have studied the wave chapter, so you will be able to recognize what is phase and what is phase difference, initial phase easily. Done guys? Understood this part? Chalo. So let's move further. So now I'll derive the equation for the S.H.M, which is the displacement, the velocity and acceleration of the simple harmonic motion. So using this example, so there will be different equations if the body starts from different positions. So here let me simplify for you. So if the particle makes S.H.M from here, so if it starts from here means at time t is equals 0, the mean position, if it makes from here, it starts performing S.H.M, simple harmonic motion. It goes to the right extreme, again mean, again left extreme, again mean position. This is called one oscillation, one complete oscillation, right? Chal. So it is performing S.H.M from here, or it can perform from this place, from here to this side, and first this side, and again mean, again right extreme, again mean. That is also an S.H.M, right? Or else the particle can begin its simple harmonic motion from here. So the left extreme position, so it will move to mean, and again right extreme, and again mean, and again left extreme. It's also S.H.M. Or the particle can make S.H.M from here to the mean, mean to the left extreme, so the left extreme to mean, mean to the right extreme. That's also S.H.M. So for these 4 different cases, we are going to obtain 4 different equations of the S.H.M. Okay, so that I am going to represent here. So just follow carefully. So the derivation part you need not to worry, but the equations what I am going to get, so that you have to remember. Okay. So write the equation of displacement, velocity and acceleration in terms of time for S.H.M whose initial position is as shown. So which means at time t is equals 0, so the particle is performing S.H.M from the mean position towards right extreme, right? Also draw graphs of x versus t, v versus t, a versus t, right? Sure. So first let me consider the general equation of the S.H.M. I am taking it as. So as it is making the S.H.M in the x direction, so the x is equals to a sine omega t plus phi, right? So at time t is equals 0, so the particle's displacement 0. At time t is equals to 0, so the particle's displacement is 0. So then I am putting those values here. At time t is equals 0, so the particle's displacement x is equals to 0. Then so the x is 0, a sine, so here this is omega into 0 plus phi. Done. Chalo. So 0 is equals to a sine here, so this will be phi. So that means, so the sine phi is 0. The sine phi is 0. So if sine phi is 0, so then the phi can take the values either 0 degrees or 180 degrees, because sine 0 is 0 and sine 180 is also 0. So the pi can take either 0 degrees or the pi can take 180 degrees, or which we can write pi. Done? Clear everyone? Chal. So now see whether it is 0 or pi in this case. How do we decide? Let's go for the velocity equation. So what I am doing is, let's write the velocity equation. So what's the equation for the velocity? Displacement we got x is equals to a sine omega t plus phi, right? Chal. So then, so the velocity will be simply the dx by dt, the dx by dt. So then, so what will be the a constant, sine differentiation is cos omega t plus phi. Again the differentiation of the omega t plus phi. So phi differentiation is 0 constant and omega t differentiation will be omega. So therefore, so the velocity we got a omega into cos of omega t plus phi. A omega into cos of omega t plus phi, right? Chalo. Now, so observe at time t is equals to 0, so the position is 0, but the velocity should be, it's going towards the right extreme. The particle is moving towards the right extreme, so the velocity should be positive. The v should come out to be positive, right? Because the right side we consider it as positive. So here at time t is equals to 0, let's write the velocity is equals to a omega into cos of, so let's say phi. Now, so this is however constant, a omega is constant. So now if the velocity has to be negative, so then the cos phi should be negative. The cos phi should be, sorry, velocity positive, right? If the velocity has to be positive in this case, so the cos phi should be positive. Now for which value of cos we get the positive? Because the phi value we got 2. So one is 0 degrees or one is 180 degrees. So if you substitute cos 0, so it's a positive. So because this whole value comes out to be positive, because this is cos 0 is 1 and AW is however positive, so the whole velocity will be positive. But if you take pi is equals to phi is equals to pi, so then so the cos pi is -1 and this overall velocity will become negative. So that's why in this scenario we consider, so the phi is equals to 0. The phi is equals to 0. So then I will substitute it here. So then the velocity equation I get it as, so what's the velocity equation? A omega into cos omega t plus phi. So the initial phase, the phi is 0 degrees. So then the velocity equation will become a omega into cos omega t. This is the velocity equation if the particle is performing S.H.M from the mean position towards the right extreme position. And what's the displacement? So the displacement is going to be x is equals to, so phi is 0. So the displacement will be, so a sine phi is 0. Phi is 0 sine omega t. This is the equation for displacement of the particle, and this is the equation for velocity of the particle when the particle performing S.H.M from the mean position towards the right extreme position. Done? Chalo. So next, so we have, so the v is equals to we got, so then acceleration is equals to, you can do simply one thing. So we know the acceleration formula, minus omega square x. That's it, right? So then acceleration is equals to minus omega square into x. What is the x here? So the x is nothing but a sine omega t. I'll substitute that one here. X is equals to a sine omega t. That's it. Done, guys? Understood? V is equals to a omega cos omega t. X is equals to a sine omega t. And acceleration is equals to minus omega square x, you remember. So therefore I can write, if the particle is performing S.H.M from the mean position towards the right extreme position, you just remember this equation of the S.H.M as x is equals to a sin omega t. So then you just differentiate it. The velocity will be a omega into cos omega t, and then the acceleration will be equals to minus a sin omega t. You just remember the displacement. So the velocity is the differentiation of displacement, and acceleration is a differentiation of velocity, or the acceleration you can write minus omega square x. Done. So minus a, sorry, this one is minus omega square into x. What is x? A sin omega t, right? Chalo. So that's what I wrote here. This one, and this one. These three you have to remember. So in the similar manner, so I am not going to do for all the derivations. So in the similar manner, so if the particle is performing S.H.M towards from the mean position at x is equal to 0 at t is equals to 0. So then in this case, so the equation for the S.H.M will become simply minus a sin omega t. That's it. Minus a sin omega t. Done. This is the displacement when, so when it is performing S.H.M from mean position to the left extreme position. Then what is the velocity? So the velocity v is equals to, so minus, differentiate this one, minus a omega into cos omega t. This is a velocity equation. And then, so then what is the acceleration? So you just remember this way, minus omega square x, minus omega square into what is x if it is performing S.H.M towards a left extreme position from the mean position. So minus a sin omega t. That's it. So here minus of minus, it will be plus. So a omega square into, so sin omega t. A omega square into, so sin omega t. See, we can draw graphs for these also. Yeah, so I forgot for the previous one. So let me draw the graphs also. So for which one we'll draw graphs? So first the x versus t curve we draw. So the x is equals to, we got a sin omega t. A sin omega t. So now if you draw the equation graph for right, chalo. This is how it looks like. So it starts from x is equals to sinusoidal graph, x is equals to a sin omega t. So it starts from, so the mean position 0, and then so t by 4, so then t by 2, so 3t by 4, then t. Yes or no? So if you want, you can substitute here omega 2 pi by t. So 2 pi by t into, in place of time, t by 4 if you write, so 2 pi by t into t by 4. So here t cancel, so this is going to be 2 ones are 2 twos are, so sin 90 it's going to be 1. So 1 means this is going to be maximum. You already know the sine graph from maths, right? So that's why I directly drew this one. So then the x versus t curve done. So this is a x versus the time period t. Now so if I take, so the velocity time graph, what if I take the velocity time graph? So the v is equals to a omega into cos omega t. V is equals to a omega into cos omega t, right? So chalo. So now if you draw the, so v versus t curve, v versus t curve. So then, so the cos, it should start from the maximum position. Yes or no? So the graph should start from here. So this is 0, and then so t by 4, so t by 2, 3t by 4, and then t. Understood, guys? Clear? So this is v versus t. Similarly, you can draw for a versus t. So shall I draw it in next slide? Yeah. So let's take the acceleration a is equals to, so we got, so minus omega square into x. What is x here? A sin omega t. So the sine graph, it starts from the sine graph. Sine graph is always the starts from the origin, right? So then if it is negative, it starts in the negative half cycle. So if it is positive, it starts with the positive half cycle. So let me draw the graph so that you will understand better. So it starts from mean position for sure, the a versus t, So but here minus, so that's why, so again ghost has come, ghost, cyber ghost, and then yes, right. Chalo. So it starts from, so like this, so 0, so consider t by 2, t by 4, so t by 2, so 3t by 4, and then t. Understood, guys? Clear this part? Chal. So let's move further. So this is about the displacement, velocity and acceleration graph. So when the particle is performing S.H.M from the mean position to the right extreme position. So now what about in this case? Let's draw for this. So can you guys draw for this one the x versus t? I'll draw the rough graphs directly here, or else I'll draw it in the next slide. So we got the equations. So the x is equals to minus a sin omega t, and then so v is equals to minus a omega into cos omega t, and then the acceleration a is equals to minus of minus plus, it will be omega square into a, what is x sin omega, a sin omega t. So now if you draw the curve of x versus so let's draw the curve of x versus t, the x versus t curve. So minus sine, so that means it starts from, so the negative half cycle, and it will be like this, the graph will be like this. And then if you draw the v versus t curve, so the v versus t curve, so what's that? So minus cos omega t, so minus a cos omega t, cos is maximum, minus maximum, that means, so like this. Yes, sure. So then what about the a versus t curve? The a versus t curve, so here it should be positive. This is a versus t, so this is v versus t, and this is a x versus t. So this is for the x is equals to if it is starting from the mean position towards the left extreme, the equation is x is equals to minus a sin omega t. Done. So similarly you can also draw for, so if the particle is starting from here, so then the x is equals to a cos omega t, x is equals to a cos omega t. If it is performing at x is at t is equals to 0, x is equals to a position, right extreme position, so then the equation of S.H.M will be x is equals to a cos omega t, guys. And here what will be the velocity? So minus a omega into sin omega t, and then so what's the acceleration? Minus omega square into x. What is x? A cos omega t. So these are the this is the equation. So now you can draw the x versus t, v versus t, a versus t graphs. You can draw it easily, right? You know. So the x versus t, v versus t, a versus t graphs. So take it as a homework for this. Done. Clear, guys? Chalo. So we have one more condition. So when the particle is starting from the left extreme at time t is equals 0, x equals to minus a. So then if it is moving towards a mean position, so here x is equals to minus a cos omega t. Then so differentiate the displacement, you will get the velocity, which is a omega into, so the cos omega t, a omega into cos omega t. So then what will be the acceleration? Minus omega square x. So in place of x you can write minus a cos omega t. So here, so minus of minus plus a omega square into cos omega t. This is the acceleration. Done. So this is the velocity, and then this is the displacement. And similarly you can draw the x versus t, v versus t, a versus t curves. So the x versus t, v versus t, a versus t curves. So take it as a homework. Done. Clear, everyone? Sure. Done. So hope you understood the cases. So let me just summarize before going to the questions. So I'll just summarize. So if the particle is making S.H.M at x is equals to 0, So this is the right extreme plus A, and this is the left extreme. Just let me summarize in 2 minutes. So at x is equal, at t is equal 0, if it is starting from x is equals to 0, so towards the right extreme position, so then the equation for the S.H.M is x is equals to a sine omega t, guys. So then the velocity will be equals to a omega cos omega t, and then the acceleration will be equals to minus omega square into a sine omega t. So this is the basic and most popular equation of the S.H.M. If they don't give anything in the question, we have to consider it's performing S.H.M from the mean position towards the right extreme position. Done? Chal. So next, so the second case is if it is from mean position, so towards the left extreme position. So here it is minus a, here it is plus a. So then in this case, so the equation of S.H.M will become x is equals to minus a sine omega t. Done. At time t is equals to 0. So here also x is equals to 0, but towards left extreme it's moving. So then the velocity will become minus a omega cos omega t, and the acceleration will become, so minus of minus will become plus omega square a sine omega t. Done. Chalo. So next, so then, so if it is a mean position, so towards the right extreme plus a, towards so the left extreme minus a. So then, so if it is starting from the x is equal at time t is equals to 0, it's starting from x is equals to plus a. In this case, so the equation of S.H.M is x is equals to a cos omega t. So then, so the v will be equals to minus a omega into sine omega t, and the acceleration a will be equals to minus a omega square into so the cos omega t. Done. Clear? Chalo. Next, so the last case, if the particle is performing S.H.M, so this is a mean position, this is plus a position, so this is the minus a position at time t is equals 0. So if it is starting from x equals to minus a, so in this case, so the x is equals to minus a cos omega t, and then v is equals to a omega sine omega t, and then so the acceleration is equals to, so minus of minus plus omega square into a cos omega t. Right. So the last case that we have seen, a omega cos omega t. So this is a omega square cos omega t. Done. So these are the 4 scenarios. So this is the most popular one, and this one also. Done, guys. Clear? Chalo. So just let me write them this way. So till now whatever we have studied in the last 20 minutes is the whole thing is here. Done, guys? Clear? Chal. So let's see the question. So what's the question says? So the oscillation of a body on a smooth horizontal surface is represented by, the equation is given in the question, x is equals to a cos omega t. Right? Chal. So then where x is the displacement at time t, so omega is the frequency of oscillation, when which of the following graphs correctly shows the variation with t. So the acceleration versus time curve we have to see. So if x is equals to this one, x is equals to a cos omega t, what will be the velocity? So minus a omega into sine omega t. Right? So then what will be the acceleration? See, directly you can go for this. Velocity is also not required because you know the acceleration equation, right? Minus omega square x. So a is equals to minus omega square. In place of x, I can write a cos omega t. So cos starts from maximum here, as it is minus here, so it starts from negative, right? So negative maximum it starts. So the option 3 is the correct one, guys. Yes or no? So you might get confused between option 1 and option 3, as the acceleration is minus omega square cos omega t. Which situation it is? The particle is performing S.H.M from the right extreme position. So which scenario? the right extreme scenario. So in that case, the acceleration is minus a omega square cos omega t. So for that, the graph will be this one. Done. Clear? Chal. So then, so write an equation for x, v, a and also draw graphs for x, t, v, t, a, t. Find the phase difference between x and v. So v and a and x and a. Okay. So this already we did. Write the equation for x, v, a. Also draw the graphs for x, t, v, t, a, t. So when the particle is starting performing S.H.M from the mean position towards the right extreme position. So in this scenario, the displacement equation, the first most popular scenario, this one. So x is equals to a sin omega t, we know that. So the v is equals to a omega into cos omega t. So this also we know. And the acceleration, we know that. So minus omega square into x. So which is a sin omega t. These are the three equations we can simply write. Chal. Now, so they are asking what is the phase difference between x and v. X and v. So v and a and x and a. So here you have to concentrate. So to find the phase difference, the phase is, this one is called the phase. Omega t is the phase. Here omega t, here omega t. So if they are in same trigonometric functions, so then you can write the phase difference, guys. But it is in sine, it is in cos, and it is in sine again. So now what I am doing is, so let me write everything in terms of sine. So this one I am writing a sin omega t, let it be a sin omega t. So the second one also I am writing in terms of the sine. So a omega into, so the sine of, so omega t plus pi by 2, omega t plus pi by 2. So sine of 90 plus theta. What is sine of 90 plus theta? So the cos theta. Yes or no? So the sine of 90 plus theta. 90 plus theta is in the second quadrant. In the second quadrant, sine is positive. So that's why a omega into sine of 90 plus theta is cos theta. So this comes out to be again a omega cos omega theta. Then, so this one I am writing. So omega square a into sine of, let's write, so omega t plus pi. Omega t plus phi, sine 180, see here. So this one I am writing sine of, so 180 plus theta. I am writing sine of 180 plus theta. So sine 180 plus theta is in which quadrant? So the third quadrant. In the third quadrant, sine is going to be negative. It will become again minus sine omega t, right? So minus sine omega t means minus omega square a sine omega t it will become. So now all are in sine functions. See, basic maths you already know. We already dealt 2 lectures for the basic maths. So this one, the sine of 90 plus theta is equals to cos theta plus cos theta. This we already know. Done. And what about sine of 180 plus theta? Sine of 180 plus theta in the third quadrant. So in the third quadrant, sine is negative, and if 180 is there, sine remains as sine. So it becomes minus sine theta. So these two trigonometric tricks I have used here. Okay, chalo. So then now you can observe the phase difference. So here the sine omega t, here sine omega t plus pi by 2. So that means, so the phase difference between, so x and v, so the phase difference between x and v is pi by 2. The phase difference delta phi we write, so which is pi by 2. And so the v and a, again the phase difference is pi by 2. This is pi by 2, this is pi minus pi by 2, so which is pi by 2. And the phase difference between x and a, so which is the phase difference is phi. Done. Clear, guys? Understood, everyone? Sure. Next. So we got the simple question. So what's the question says? So average velocity of a particle executing S.H.M in one complete vibration. So here it can start from the mean position, or it can start from the right extreme position, or any graph you can take. So from graph you can answer this question easily. So in one complete vibration. So let me consider, so the equation of S.H.M as x is equals to a cos omega t, which is starting from the right extreme position. Any equation you can consider. Okay, so then the equation for this will become like this. So this is a V versus T curve. Sorry, not V versus T. So this is a curve. So then the total average velocity. What is the average velocity? This is a X versus T. So then the average velocity is equals to the total displacement by total time. So it's a total displacement by total time. The total displacement by total time. So now if you observe the total displacement, whatever the displacement here and here, so it will be cancelled by, so the displacement of this one. So that means overall, so the total displacement is 0. So the average velocity, the V average will become 0. Overall, so the V average will become 0. Option 3 is the correct one, guys. Understood? Clear? Sure. So let's go for the next question. In S.H.M, the phase difference between displacement and acceleration. So between displacement and acceleration, it is pi. So just now we have seen. So between displacement and velocity, pi by 2. Between velocity and acceleration, pi by 2. Between displacement and acceleration, pi. So if you want, you can write the equations also there. Done. Chalo. Simple questions. That's why I'm going a bit faster. So the phase difference between the instantaneous velocity and the acceleration between V and A. So it should be pi by 2. So pi by 2, 0.5 pi, which is nothing but pi by 2. So 0.707 pi, no. So the next question. So what's the question says? A particle of mass m is released from the rest and follows a parabolic path as shown in the figure. So assuming that the displacement of the mass from the origin is small, so which graph correctly depicts a position as a function of time? So first, from where the particle is beginning its oscillation or S.H.M, at t is equals to 0, at x is equals to plus a. So what's the displacement function we get for that? A cos omega t. From right extreme, it's starting its S.H.M. That's it. So x is equals to a cos omega t. So then I need the x position versus time. X equals to a cos omega t. So then the x versus t curve starts from the maximum position to here. So the correct graph is option 1. I could see directly. 0 you can eliminate. So this you can eliminate. So the graph should not be like this for the cos. So this is also not a cos graph. Done, everyone? Sure. So the next question. So what's the question says here? An object performs S.H.M, so of amplitude 5 centimeters and the time period 4 seconds. If timing is started when the object is at the center of the oscillation, that is x equals to 0, then calculate the displacement at t is equals to 0.5 seconds. Write the given information. So the amplitude 5 centimeters. So the time period 4 seconds. And we have to calculate the displacement, at 0.5 seconds. So 0.5 seconds, or you can write 1 by 2. Right, chal. So then, so the hint is given if timing is started when the object is at the center of oscillation at x is equals 0. So at x is equals 0, it starts its oscillation. So we'll take the most general one, that is the x is equals to a sine omega t. That's it. So what is omega here? In terms of time period you should write. So the omega is equals to either you can write 2 pi by t or 2 pi f. So here in terms of time period they gave, so I'll write in terms of the time period, the formula. So the x is equals to, what's the x? The displacement. So it starts from x is equals to 0, right? Sorry. So its amplitude is what? An object performs S.H.M of 5 cm. We have to find this x, right? Which is equals to, so a, what is a? 5 into sine. What is omega? Let's write 2 pi by t into, so the time t. So then the x is equals to 5 into sine of 2 pi by, so the time period is 4 into, so what is the time t? So this I am writing it as 1 by 2 seconds. So in place of t, I am writing 1 by 2. So t sorry, 2 gets cancelled. So then I can write x is equals to 5 into sine. So what is left here? So the pi by 4. So sine pi by 4 is root 2, 1 by root 2. So 5 into 1 by root 2. So check for the option. So 5 by root 2 centimeters. Option B is the correct one. 2. Option 2 is the correct one, guys. Understood? Right? Am I going fast? Simple questions, right? So that's why bit faster. Chalo. So the next question. So you can try it on your own. Pause the video. A particle executes S.H.M from the extreme position they mentioned and covers a distance equals to half of its amplitude in 1 second. So the distance covered is x is equals to a by 2, half of its amplitude. So in 1 second. So the time is given 1 second. Then determine the time period of the motion. So what we have to calculate? So the t is equals to what? Capital T. So the particle executes S.H.M from the extreme position. So I will consider the right extreme is the most popular one. So what is the right extreme formula? A cos omega t. Yes, sir. So then, so the displacement is given. So what's that? A by 2. So which is A into cos. In place of omega, I am writing 2 pi by t. So in place of time t, I am writing 1. So here 1 a cancel, 1 by 2 is equals to cos of, so 2 pi by the t. So then cos of which value is equals to 1 by 2? Cos of which angle is equals to 1 by 2? So cos 60, right? So that's why. So here, so the 1 by 2 is, or else I'll write this way. So the cos here I'll write. So 1 by 2 means cos 60. So 60 is always write it in the radians. Cos pi by 3 is equals to cos 2 pi by t. So then simply compare. So 2 pi by t is equals to pi by 3. So 2 pi by t is equals to pi by 3. So done. So pi cancel. So the t is equals to 6 seconds. So the total time period will become 6 seconds. Option 3 is the correct one, guys. Done? Clear? Chal. So let's move further. So we got one more question. So the 10th question. A particle executes simple harmonic motion at x is equals to 0 at time t is equals to 0. So it has a displacement x is equals to 2 centimeters is given information and 0 velocity. So the velocity 0. So if the frequency of the motion is given. So the frequency is 0.25 Hz or second inverse. So find the displacement at t is equals to 3 seconds. So at t is equals to 3 seconds. So what is its displacement? So the x is equals to how much? So the particle starts its S.H.M from the mean position. X is equals to a sine omega t. So then you know the frequency. So in place of omega you can write 2 pi f. So the v is given as 0. So what's the v equation will become? So it will be a omega into the cos omega t. Right. So substitute v0 and a you can calculate from the x is equals to a sine omega t. So then substitute this and get the only unknown is the displacement. You have to find the x. So take this as a homework. The simple question, same previous type one. Right? Sure. So the homework 1, consider the graphs I gave it as a homework 1. So this you can take it as a homework 2. So a particle executes S.H.M with a time period of 4 seconds. Find the time taken by the particle to go from, not got from, it's a go from. So to go from its mean position to half of its amplitude. So assume the motion of particle to start from the mean position. So they gave a particle executes S.H.M. So the time period, what's the given information first? So the time period is 4 seconds. And then find the time taken by the particle to go from mean position to half of its amplitude. So the mean position to half of its amplitude. X is equals to a by 2. So starts from mean position. So we have mean position means x is equals to a sine omega t. So we have to find the time taken. So x you know. So time period omega, in place of omega you can write 2 pi by t. X also you know. So which is a by 2. So simply substitute and get the t value. So here it will be a by 2 is equals to a into sine of 2 pi by t into, so t, that's it. So now you can go for the value. So answer. Understood? So take this as a homework, remaining part. Done? Clear? Chalo, next we have a particle executes simple harmonic motion, simple harmonic oscillation with an amplitude A. So the period of oscillation is T. The minimum time taken by the particle to travel half of the amplitude from the equilibrium position. Yes, I'll explain this. So this is a standard conclusion also. So after solving this, we'll write the conclusion. See. So a particle executes simple harmonic oscillation with amplitude A. So the period of the oscillation is T. The minimum time taken by the particle to travel half of its amplitude from the mean position. So that means the particle is starting from, let's say, the mean position. So at time t is equals 0, the x is 0. So it is moving towards the right extreme. Then, so its displacement is the x is equals to a by 2. See here. So the minimum time taken by the particle to travel half the amplitude from the equilibrium position. So the displacement a by 2. So now try to follow the given procedure clearly. So the x is equals to a sin omega t if it starts from the mean position. X is equals to a sin omega t if it starts from the mean position. So now, so the x, how much displacement it has traveled? A by 2. So then, which is equals to a. So the time period is given. So in place of omega, so I am substituting the time period as 2 pi by t. So then this t I have to calculate. So then this cancel. So then I can write. So 1 by 2 is equals to sine of 2 pi by t into, or else let's keep omega t only, better. So later we'll do the calculation of t. So here let it be omega t. So sine of which value will be 1 by 2 guys? Sine 30, right? So sine 30 means, so this will be sine pi by 6. Shall I write this side? Sine 30 is 1 by 2. So that's why sine pi by 6 I am writing here. So then sine omega t here. So then if you compare, so the omega t is equals to pi by 6. So in place of omega I am writing 2 pi by t. So in place of omega I am writing 2 pi by t into the time period t is equals to pi by 6. Okay, done. Chalo. So then pi cancel. We have to find what is t here. So the t is equals to 6 into 2, 12. So this t will go up. So t by 12. So the time taken from, so the mean position to, so half of its amplitude. So it will be t by 12 seconds. So now the important conclusion that you had to remember. So the summary or the conclusion you have to remember from here, it is, so if the particle is making S.H.M from the mean position, so that is, this is the mean position, so the x equals 0, the time t is equals 0. So then it is moving towards a right extreme plus a, let's say. So then to cover half the distance, it is taking, so t by 12, the total, you know that the total time taken from here to here, it is t by 4. From here to here t by 4, from here to here t by 4, from here to the left extreme t by 4, again from left extreme to the mean t by 4. Total 4 t by 4s, so which is total time period t. Now, so you know that from mean position to half of its amplitude, let's say this time period is t1. So let's say the time taken, this is t2. Now, so we got this time t1 as t by 12. Sir, then this also will be t by 2 now. It will take first half it covered in t by 12 seconds. The second half also will it cover in the same time? No, because so the mean position to the extreme position, so the velocity decreases. So near the mean position the velocity will be more. Here the velocity will be more and decreases. And then when it comes to the right extreme position, the velocity will become 0. Right? So that's why, so here in this period it takes the less time. Here the velocity is less, it takes more time. So the first conclusion that you can write, so the time t2 will be greater than that of the t1. This is the first conclusion you have to make. So it will not cover equal distances in equal time. No. So here it takes less time, here it takes more time, because the velocity keeps decreasing from mean position to the extreme position. Very important. And what is this time t2, sir? So this time t2 is equals to, I can write, So the T1 plus T2 is equals to T by 4. The T1 plus T2 is equals to T by 4. So then here what is T1 I got from mean to the half of its maximum amplitude. So which is T by 12 plus the time T2 is equals to T by 4. So which is nothing but the T2 is equals to T by 4 minus T by 12. So then if you take the LCM, so it will be 3T minus 1. So T, so which is nothing but 2T by 12. So which is nothing but, so T by 6. So the T2 time is T by 6. So which means, so if you multiply it with 2, so it will be T by 6 again. So that means the T2 will be equals to, so I can write the T1 will be equals to 2 times the T2. The T1 will be equals to 2 times the T2. Yes sir, sorry. What's the T2 that we got? The T2 only, right? T by 4 minus T by 12. So 12, so it goes 3 times. So 3T, sorry. So it is 3T minus it goes 1. So, sorry, just a minute. Yes. Oh, fine. Okay, fine. Sure. So here, so this is 2T by 12. So which is nothing but T2 is equals to, so 2T by 6. Now, so shall I say that, so the time taken in the second case will be equals to 2 times that of the time taken in the first case. The time taken in the second case will be equals to 2 times that of the time taken in the first case. T2 is greater than T1. It takes more time. So in the first case it's taking T by 12. In the second case it is taking T by 6. Right? So this whole time T by 6 and T by 12 will be T by 4. Getting? Understanding this point? So that this time will be more, this time will be less. Done guys? Chalo. So next, see if you want you can substitute it here. 2 into what is T1? T1 is T by 12. So this is going to be again 2 1s are 2 6s are. So we are getting again T by 6, right? So T2 is equals to T by 6. Done. So the important conclusion, important result. Directly you can remember the questions can be framed based on it directly. So a particle executing S.H.M is initially at the right extreme if the amplitude and the time period of the, so velocity, see take this as a homework 3 guys. So take this as a homework 3. So this as a homework 4. We have many questions. Simple questions, but all are simple questions. Homework 5. So this question is based on just we discussed it now. So it's based on this. So T2 is equals to 2 times the T1. So you can go further. I think this must be T2 here. Okay, chalo. So this question is also based on the question that we discussed just now, the conclusion that we discussed just now. So it is also the homework 5. So homework simple questions only. I am giving it as a homework for you guys. Okay, if you are having any doubts, so then you can comment. I'll discuss it in the next session. So simple harmonic motion as projection of uniform circular motion. So that concept we'll discuss it in the next session. Okay. So till then keep studying. All the very best. Bye guys.